Hello and welcome to another video. In this problem, we're going to be working on arithmetic subarrays. And in this problem, a sequence of numbers is called arithmetic if it consists of at least two elements and the difference between every two elements is the same. More formally, they define it for you. So for example, this is arithmetic because the difference here is 2. This is also arithmetic, the difference is 0. This is also arithmetic, the difference is -2. And this is not arithmetic because the differences aren't the same here. So essentially what we are given is we are given an array of nums, and we are given two arrays, left and right, and we need to perform queries on this nums array where we start at the left element and we end at the right element, and we need to check, are they arithmetic? So for example, for this first query, we say, okay, starting at 0 going to 2, is this arithmetic? And it doesn't have to be in the right order, so it might be out of order. So this is arithmetic, right? 4, 6, 5, because we can just sort it and get 4, 5, 6, and that is arithmetic. 0 to 3 is 4, 6, 5, 9, which is not arithmetic. And then we have 2 to 5. So 2 to 5 is right here. So 2, 3, 4, 5, right? 2, 3, 4, 5, yeah. And this is also arithmetic because it is 3, 5, 7, 9 when sorted. So basically the second example is like this, but essentially the easiest thing to do, well, let's actually look at the constraints first of all. So the constraints n is 500, m is 500, meaning you have 500 queries on an array of 500 elements. So, quote unquote, brute force here would just be for every single query, let's just get the elements and sort them, right? And then it would be very easy to find if it's an arithmetic sequence or not. So how long would that take? Well, that would take, you would have m queries, right? And then for every query, you might have all of the elements, so that would be n. And then to sort would be log n. So mn log n, and this would actually pass, right? This is 500 times 500 times log 500, which is basically nothing. So 500 times 500 is like 25 with 4 zeros, so that would easily pass. So actually, you can do this, right? For every single query, you can just make a function that just slices into your array. For example, let's say we have the array for, let's actually take, we take this first one. It's not very hard. Actually, let's do the second one because we are going to use it for the second example as well. So let's actually take the second array instead. So we'll have -12, -9, -3, -12, -6, 15, 20, -25, -20, -15, -10. Essentially, what you can do for any query is you can basically slice whatever indices you need. Like, let's say we take these, sort them, right? So if you sort the numbers here, you would get something like -25, -12, -6, 15, 20. And then basically you just find the difference between the first two elements. So like in this case, it's 13. And then you just make sure for every other set of elements is the difference the same. So it's a very easy problem, right? Just take the query, sort, there you go. And that does work. But we're going to try to have a linear solution. So we're going to do a slight modification. It's not too bad. And the easiest way I found this after doing it a few times is it's actually easier to do a slice of the array instead of just passing in the left and the right bound and doing something. So essentially what it's going to look like, let's actually go through these queries and kind of show what's going to happen. So for the first query, we have 0 and 4, which means the slice is going to be, let's actually index these as well just to make it easier for us. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to go through these queries in this example. So 0 to 4 is going to be this chunk over here. So let's write out these elements. And we are not going to sort them this time to make a better solution. So there we go. And now basically we are asked, like, is this an arithmetic sequence? So how can you do this without sorting? So you can do it without sorting. And the way we're going to do it is we're going to get a min and a max. And if you think about it, for any kind of sequence, right, with n numbers, it's going to be like n, or the numbers is going to be like 1, and then 1 plus that whatever difference is between the two numbers, right? 1 plus the difference, plus the second number, and so on and so on. So actually, let me write another way to make it easier. So let's say we have like the first number, and then, or actually, I know the best way. Okay. So let's say we have a bunch of numbers, right? Let's say we have 5 numbers here. So the difference between any two consecutive numbers has to be some constant number, right? Let's call this like D. So basically for 5 numbers, you add the difference 4 times, right? Because you have 4 additions, and every addition for an arithmetic sequence adds that exact difference. So for example, for sequence 1, 2, 3, 4, that difference would be 1. Now basically we can calculate this difference because the difference has to be, if we take the max number in this sequence, so the max number here is -3, and the min number is -12, we get the difference there. So we're saying like, where does our array start and where does it go, right? And because it's not sorted, if it can go one way or the other, right? So we can always make it increasing if we want to, right? So basically, like if something like this is an arithmetic sequence, then the other way is also arithmetic. So like 5, 4, 3, 2, 1 is. So we're just gonna say, let's just have a min number and our max number, and let's always go increasing. So our max number will be this, our min number will be this. So we're gonna do max minus min, so we get -3 minus -12, and we get 9. So our difference is 9. Now, how many numbers do we have? We have 5. So remember, you add the difference n minus 1 times. So we have to go from, sorry, it's not the difference. This is like the total increase you need, right? So from the smallest to the biggest number, this is how much you need to add total. And how many times do we add? It's n minus 1, so that's going to be 4. So our difference here should be 2.25. Now, in any arithmetic sequence, if your number is not an integer, that means it's invalid, right? We can't add 2.25. We can't do like 1, 3.25, and so on. So right away, whenever we get a difference that's non-integer, we can just return false. So this query right away would return false. And it doesn't make sense because we have 12 twice, so this wouldn't be an arithmetic sequence. So for this first one, this is going to return us false, and let's see if that's what it was. Okay, now let's go to the next one. So we have 1, 4. So let's get this slice now, right? So instead of writing out the actual slice, I'm just gonna highlight it. So for this slice, what's our min and max? Well, our min is -12, and our max is -3. So let's do this difference again. So -3 minus -12, we get 9. How many elements? We have 4. Remember, you add the difference n minus 1 times, so 4 over 3. So now our difference is 3. Is that a valid integer? Yes, it is. So now once we get a difference, all we have to do is we have to traverse from the min. Oh, and there's one more thing I forgot to say. So there's one more step, but because our difference failed the first time. So what we're going to do is we need to somehow figure out like how to get rid of duplicates, right? Because the only way you can have duplicates and have a valid arithmetic sequence is if your entire sequence is all the same number, right? So like the 7777 thing. So what we're going to do to get rid of duplicates is turn this array into a set, right? So we're going to turn this array into a set. So what's going to happen here is, in this case, this is going to be the same thing. And we're basically going to say, okay, let's start at the minimum number, which is -12, and let's just keep adding the difference until we get to the maximum. So we need to get to -3. And anytime we add a number, let's just check, is that number in our set? And if that number is in our set, that means by the time we go from the min to the max, we would have a valid arithmetic sequence, right? So we start at -12, we would add 3. We go to -9, that's in our set. Okay, we add 3 again. Go to -6, that's in our set. Add 3 again, go to -3, that's in our set. So every single number was in our set, and we added the same number every time. So we know this is a valid sequence. So that's how you could do it. You just take an array, convert it into a set. And I found it's easier to take an array, convert it into a set, than to take indices and convert them into a set, because there are a lot of like edge cases for that. So it's easier to take the array, and because you're using a set anyway, your space is going to be O of n anyway, so it doesn't really matter. Yeah, so the second one will be true. So this is done, this is done. Actually, let's get rid of this line here. Okay, so there we go. So this is done, this is done. Now let's take our third query. So our third query is 6, 9. So that's going to be over here. And yeah, so same thing, calculate our difference. So our difference is going to be, smallest number is -25. Biggest number is 20. And then we get the difference. So that's going to be 20 minus -25, which is 45. How many elements? We have 3. We have 4 minus 1, right? You add the difference n minus 1 times. So 3 here, this is difference of 15. We have valid difference. Now, what's the smallest number? We start at negative 25 and we keep going. Remember, we convert this into a set. So basically, when we convert it into a set, it'll be negative 25, 20, and negative 15. Actually, no, these are all unique numbers. Never mind. These are all fine. Right? Yeah. Okay. So we go to negative 25. That's in our set. We add 15. Then we have negative 10. And negative 10 is not in our set. So this should be false, right? Because this should be, our difference for this to work has to be 15, but negative 10 is not in our set, so this is invalid, right? So we just traverse up. Anytime your number is not in your set, then you know this is invalid. And indeed, for this to be valid, if it starts at negative 25 and ends at 20, it would have to be negative 25, negative 10, 5, and 20, right? For a 4-number sequence, this is what it has to be. So essentially, we can easily figure out, like, what does it have to be and just check, are the numbers in our set? So for this one, we're good. Let's keep going. For the fourth one, we have 4 and 7. Let's actually do this. Okay, so for 4 and 7, so same thing. What's our min and max? So our min is negative 25. Our max is 20. So our difference here is 45 over 3, which is, hopefully I didn't do the same one twice. I don't think so, but let's find out. Yeah, well, I guess we'll see. Okay, so our difference here is 15. I don't think we did, but anyway. Yeah, so our difference is 15. So we do the same thing. So we start at negative 25. And we add 15, right? So add 15. We get 10. Or we get negative 10, sorry. So is negative 10 in our set? So our set would be these numbers. Obviously, we're going to see like this negative 6 can't be in here. So this clearly can't be clearly can't be an answer. But negative 10 isn't in here. Once again, this had to be negative 25, negative 10, 5, and 25 for it to work. So this is clearly not a valid arithmetic sequence, so we can say false for that one. And we have 2 more. So we have 8 and 9, so 8 and 9 is right here. So what's our min and max? Negative 20 and negative 15. Obviously, for any 2-length arithmetic sequence, this is always going to work, but let's just do it anyway. So our difference here is 5, and it's 5 over 1, right? 5 over n minus 1, so 5, valid difference. Now we start at negative 20, add 5, negative 15, right? So we got from our minimum to the maximum, and it's a valid sequence. So this is going to work. So true there. And finally, for the last one, we have 7 10s. So 7 10s are over here. Okay, so the minimum is negative 25. The maximum is negative 10. So the difference here is 15. And our elements is 4 minus 1, so 3. So our difference is 5. Now we check all our elements. So we have negative 25. That's in there. We add 5. We get negative 20. That's in our set. Add 5, negative 15. That's in our set. Add 5, negative 10. And that's also in our set. So we managed to get from the smallest to the biggest element. So this is true as well. So that's kind of basically, as a sum up, we're going to have a helper function that will just take an array, get min and max, calculate difference, check if it's valid, right? If it's not an integer, we can just return false. Try to get from min to max with adding difference each time. And if we have all elements, then we made it, right? Okay, that's basically it. So it's a lot easier with sorting, but this is also not too bad, and this should be faster in theory. Okay, so let's code it up. So we're going to make a helper function at the top, and then we can just process our queries. And this is kind of an easy problem just because you can basically process every query without doing any kind of pre-processing. Like, you can literally just run this, you know, and you don't need, especially with the sorting way, you don't need any kind of optimizations. Like, normally, when you, for harder problems, when they give you a bunch of queries, you can't just run the queries directly. You have to do some, like, optimizations. Because, especially for a query like this, it's very easy to check if something is in an arithmetic sequence by sorting. So we're going to say def query checker. It's going to take an array. We're going to get a min item equals min array, max item equals max array. Now we're going to get our difference, so we'll just say diff equals max item. We could have actually done this in one line. That's fine. We're going to reuse variables anyway. So max item minus min item over the length of the array minus 1. Now we need to check, is our difference an integer? Easy way to do that is you can just say if difference mod 1. So basically what's going to happen here is if it's like 2.25, you will get 0.25. So if this is non-zero, then we have an invalid difference, so we can just return false. Okay, now we do uniques is our set of all our numbers to get rid of the duplicates, and we'll say cur is min item, and we'll basically say while cur is less than max item, and we just keep checking, is our current item in uniques? If it's not, then we can return false, right? So if cur not in uniques, let's return false, and we'll just keep adding the difference. And finally, at the end, if we made it through this whole thing, let's return true. So now at the very end, this is very simple. All we need is a result array, and we can basically say for I in range one of the lengths, left or right, we'll just pick right. So we can append the actual result of the query, right? So we're append query checker, and then we basically have to slice this array. So it'll be nums. The left index is going to be left I, and then the right index is going to be right I plus 1, right? Because it's not inclusive. So if left was 0 and right was 3, you want to have 0 and 4 here for the slice. Then it'll go 0 to 3. Essentially append them all, and finally return result. And yeah, this is easier than passing in indices and making a set right away, because if you do that, there are a lot of edge cases, and I did that before, and this is like 10 times easier. So I definitely recommend this. And like I said, in actual theory, this doesn't cost you anything because you're still making a set. In practice, it will take up a little bit more space because, like, let's say your array is all your items, you know, your array has a ton of duplicates, then you are, you know, this does take more space in the set. But on the bright side, this runs a lot faster and has way less edge cases if you just pass in an array directly instead of indices. So let's try that. And there we go. Very efficient solution. Yeah, better than sorting. Like, I think this problem with sorting is probably like a very easy medium problem, I have to say. And then without the sorting, it becomes like an actual medium problem. And let's think of the time and space here. So we are performing m queries, so that's already m. For every single query, we are slicing the array, and worst case scenario, obviously that whole array is length n, right? So that array can be length n, and we are going through our entire array. So turning an array into a set also takes the length of the array, so that's already length n, and then going from the smallest number to the biggest number. Worst case scenario, you're basically going through, like, if your array is all unique elements and it doesn't make up a valid arithmetic sequence, then this part would also take length n. So it's like length n and then length n, which is just length n total. So for every single query, it's going to take n time, and then we have n queries. Yeah, and we saved that n log n from not sorting. So space. Basically, every single time we are building an array that we're turning into a set, so that's just O of n, because our array can be every single element in this nums. And yeah, I think that should cover everything, so hopefully you liked this one, and if you did like it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.